So today I've been asked to go over a few features on behalf of a customer. So I just thought I would do this video, which of course I will then share on my channel for other people to watch. So in terms of the topology that we're going to be using, so I've got a SD-WAN environment here with two downstream spokes. The left-hand spoke is a FortiGate managing a Forti switch, and then I've got a Linux host behind there connecting up to a virtual instance representing the internet. I've got spoke 2 here. This Linux client is directly connected to a port on spoke 2. Then I've got two hubs. Forgot to label hub 1, but they should be obvious, and they then go into AWS. There's another FortiGate in each one of AWS, and then this connectivity here is via IPsec, and then I've got another IPsec tunnel crossing between the US and the UK here, and within that IPsec I've got VXLAN, so that I'm extending the same subnet across the ocean. So these two Linux servers on both sides here believe that they're sitting in the same data center, albeit separated by a good few thousand miles. So the SD-WAN steers traffic accordingly, either via the hubs up to the cloud or direct internet access directly out for applications that are that don't need to go via the hub. Now, if spokes need to speak with each other, they will use ADVPN. So ADVPN relies on BGP. So all of this has got BGP running. So basically, this spoke 1 will send a packet. The first packet will go up to the hub. The hub will respond back with the shortcut information about the external interface of spoke 2, and a direct IPsec tunnel is set up between those two devices. So the features that the customer has requested to see are NAT, specifically IP pooling or overload, which is where you use more than one IP address on an external interface so that you don't end up with port starvation. Now obviously when you're doing NAT is using a cascade of TCP ports. You've got 65,535 ports available. If those get exhausted, then obviously traffic will stop. So you have more than one IP address as long as your external subnet facilitates that, and then it will share that across the various IPs that are available. The next thing the customer wanted to see was BGP, and as I said, the whole framework relies on BGP, so that's quite easy to show. Then we'll look at policy-based forwarding, and finally traffic policing. So here are my devices. So I've got my spoke 1, spoke 2, and my two hubs. All right, hub 1, hub 2. So let's just start off with the spoke. So as I mentioned in the title, or rather I didn't mention it, but it said in the title, a FortiGate is not simply a firewall, it is a multifunctional security platform, right? So there's a lot more in this than you're going to have in a traditional firewall. Firstly, it is a Wi-Fi and switch controller. So depending on the model of FortiGate you have, will depend on how many access points can be managed. This particular one is not running any access points at the moment, but if it were, you'd see the total number there. So here we go. So this is a VM, this is a virtual machine. And you can see that this virtual machine can manage up to 4,096 access points in bridge mode. That's where the access point is bridging the SSIDs on a VLAN tag directly to the switch, or half that number in tunnel mode, obviously because tunnel mode has encryption, de-encryption, so it has obviously more tax. Now when I say tax, this is specific to this, which is a VM. That means tax on the CPU. The physical hardware FortiGates have got an ASIC, and the ASIC does the encryption, de-encryption of the CAPWAP traffic. So you'll find that this number will be significantly higher on a larger hardware capable FortiGate. But as I said, this is a virtual machine. The other thing we can do here is we can have switches, and again, this depends on the type of FortiGate you've got. Here I've got a single switch, and this is actually a virtual switch. It's not a real switch, but in a real world you'd have physical switches. And we can, depending on the size of the box, have up to 300 switches supported per FortiGate. So if you times 48 by 300, you get some 14,000 Ethernet ports. That can be managed from a single pane of glass on a single FortiGate with no need for any external controllers, right? So again, the APs and the switches are managed directly from the FortiGate. And you can see here, this is this virtual switch here. But I've got full control over all the aspects that I would want to do here: speed, duplex, DHCP snooping, spanning tree, and so forth, are all managed here. Anything that's not visible on the top layer there is simply because it hasn't been dragged across. So here's my inactive columns, here's my active columns, and you can see all this other stuff like quas policies, spanning tree, loop guard, and all of that. All is there. I just haven't pushed it across. So let's take spanning tree, move it across, say apply, come across here, and now I see my spanning tree is there, and I could obviously enable or disable it as required, right? And here's the rest of the features here. So it is fully functional. There's, you lose nothing. What it's just giving you is a single pane of glass to manage all these things. Again, the VLANs are created here. You can have your full 4,000 VLANs, and it just makes a nice single pane of glass to manage your entire estate. So it's your routing, your switching, your security, your Wi-Fi, your SD-WAN is all done on this one appliance. Hence why I said it's a multifunctional security platform as opposed to simply being a firewall or a router. It is the whole lot. So I'll come back to the routing in a second. So what we want to do is to see the NATing. So in terms of that, what we're going to look at here is the SD-WAN, and I'm going to come back to this for a bit more detail in a moment. But for the purposes of the NAT test, I've created a rule here, and I've said to this rule that any traffic going to this subnet to take this path, all right, to go specifically up to DC1, the hub number 1, right? Because I want to push that traffic directly to this. So if I come to hub number 1 and I look at the interfaces here, what I can see here is I've got an interface 18.10.10.1, all right? So the host is, I forget what the host was actually. Let me go across here and see what that host is. So it's the whole subnet there. So the whole subnet will match that. And then I have a policy here that says traffic to this NAT test coming from the IPsec tunnels associated with the AD-VPN, going out of port 3 to then NAT that traffic to this particular subnet. And here I'm using an IP pool. And you can see I've just put 2 addresses in that IP pool, but I could put as many as the particular subnet on the external interface supports. So basically what will happen is I'm going to drive 2 sessions along that path, and we'll see that it'll load balance. Now let's have a look at that before we start running the traffic. So let's do a diagnose system session list. So we can see here that I've got a total of 26 sessions, and if I just look for those specific IP addresses, if I go 18.10.10.10, I see nothing in there. All right, sorry, see nothing because I didn't put the word grep. All right, there's nothing there. There's nothing on 11. So I've got no sessions running for those IP addresses yet. So if I come across here to my tester, if I look at my test case here, what I'm going to do is edit it. Timed out. Let's log back in. So this is FortiTester. It's our home-built test platform. So you can see I've got one port here which is connected to spoke 1, and I've got port 2, which is connected to the destination DC. All right, so I'm going to have 2 flows coming from these 2 hosts, 5 and 6, going through to 4 and 5 on the other side. So let's start that test. So this will take a few seconds to initiate that. And then once it's started, we'll take a look at those flows. And there we go. So I've got that. So let's just come back to here. And if I look at 11, so I've got a flow there. Come to 10, and I've got a flow there. So that was the first thing the customer wanted to see, was that the IP pools were working, and that the overload works. And you can see here that it's actually load balancing, rather than sending everything to the one IP address and waiting for that to starve all its 65,000 TCP ports. It's balancing that traffic across both of them. Right, so the next thing to look at is the BGP. So if we look at the configuration here, so I've got all my protocols. In fact, we do support IS as well, but the question here is BGP. All right, so as you would expect in any router, you give it an AS, a router ID, you define your neighbors. In this case, I'm using, because this is a hub, and I'm going to have more than one neighbor coming in, I use a neighbor group. That saves me having to manually do all the neighbors. And then I just use the neighbor ranges here to say what subnets are going to be coming in from those remote peers, and they'll make them all part of that one peer group. Then I choose what subnets I wish to push down to those peers. Okay, there's that 18, 10, 10, 10. So if we come back to spoke 1, all right, and we look at that path, if I do a get router info, routing table BGP, okay, there's that 18, 10, 10 that I was using on the NAT, and here are the other subnets that have been pushed from here. So okay, so you'll see that those marry up. The one that you don't see there is the 99, and that's coming from those AWS FortiGates, which are even northbound of the hubs. So they connected to the hubs via IPsec, so they sharing BGP with the hubs, and then the hubs are then sending these the subnet downstream to the spokes, so that I've got reachability up to the cloud. All right, so again, if I look at it from this side, get router info, routing table BGP, and here is the subnet that I was driving from the spoke side in terms of the source, client source, going to that 18.10.10 destination. Now, you can also configure all these things from CLI if you so desire. All right, CLI gives you more features and functionality. We probably do about 90% in GUI, but there are things that you would want to enable here in the CLI, right? But the purpose of this is just to demonstrate that we have all that capability. All right, so hopefully that answers that question. So I'm just going to show this window for now. So the next thing was the policy-based forwarding. Now, we do support traditional policy-based routing. Okay, so you can put in your source destination, and you can change a destination so that you can circumvent the underlying routing table, in this case BGP. Now, of course, that'll work, but that's a bit primitive. That's the sort of stuff that we were doing back in the 90s. Now we've moved on to SD-WAN. So SD-WAN can be considered policy-based routing on steroids. The reason being is it goes well beyond simply layer 3, layer 4, right? So we can start looking at actual applications here. So if I delve into my Skype, for example, I can see here that I have got Skype from a internet services database perspective, okay, and which means that I can now start looking at that from an actual application perspective, rather than simply from a destination IP address. So if I just come and enable a feature here, feature visibility, if I look at application control, where am I? There we go, application detection. So that's what I'm looking for there. So if I come, so while I'm on this page, so these are all the features that are incorporated within a FortiGate. So in terms of licensing, most of these are free. By free, I mean that they come with the base license of a FortiGate. They don't incur any other costs. So server load balancing is there. The Wi-Fi switch controller is there. The SD-WAN is there. What we charge for an ongoing license perspective are your threat intelligence, right? So the antivirus, the intrusion prevention, these are all, these are effectively, the dynamic feeds that come in. Obviously, we're a security company. These would be considered value-add services, so these attract a license. But all the other stuff is included in the base license of the box. So even if your license expired, these other features would carry on working. The only thing that would stop is that you wouldn't get the updates for the dynamic threat feeds. So now I've turned on that application based. If we come back here to the SD-WAN and I look at my SD-WAN rules again, and I delve within here, you can now see that I've got application capability there as well. So the difference being is Internet Services Database is simply a whole collection of IP addresses that are related to a certain application. All right. Now that's fine, but what if one of those IP addresses were to be compromised, right? And say somebody was spoofing some other traffic along that IP address. If you were simply relying on the IP address, you wouldn't know that. What's far better is if we actually come along here and we incorporate in, so let me just Skype, the actual application. All right, so now I'm looking at the actual application there. So when that traffic comes down, so it'll reach out, it'll use one of those IP addresses, but now I'm looking in there and making sure that it is genuinely that application and not somebody spoofing some VPN, open VPN or some other sort of backdoor along that path. Then I come down and I say, well, I've got multiple interfaces. What strategy do I want to use to choose one of these interfaces? Now, I can use every single interface that I've got, but in this case, I'm using direct internet access for the Skype. So I could send traffic up to the hubs, because the hubs also have internet breakout. But that's suboptimal. We'd just be incurring latency there for no rhyme or reason. So it makes far more sense for me to send these in an intelligent fashion out of my two direct ISP links there, right? So I've chosen my ISP links. Now the link at the top by default will be the preferred one, and then it'll go down to the second one, unless there's another tiebreaker. And that tiebreaker in this case is what I've asked here, which is best quality. So it's going to use an SLA, and it's going to monitor these paths for packet loss, latency, and jitter, and then choose the path with the best quantity here that I've chosen. In this case, latency. Sorry, I couldn't think of the correct word there. Criteria is the word I was looking for. So here you can see that I can choose my various things. Now, because of my screen recording, you can't see the bottom two below here, but they say bandwidth and customized profile. If I click on customized profile, I can then use a weighting here to use percentages across all of these. But I personally just prefer to keep things simple, so I'm just going to use latency. And I can also mark and remark traffic should I desire along that path. Now the thing with, and we'll come to this in a moment when we do quality of service, but the thing to understand is that when you're using SD-WAN, when you're going over the internet, marking traffic is a complete and utter waste of time, because any marking I put on the outer header is simply going to get thrown away by the very first internet router you get to. All right, so bear that in mind. It might sound great, but it's pretty pointless if your first internet router is going to throw that away. Where this will come in useful is maybe you going over some other method, like a direct connect to the cloud, or you still using MPLS. Now, often you hear that SD-WAN replaces MPLS, but that's not always the case. Sometimes a customer still wants MPLS and they want internet access, all right? And they want to steer traffic, some traffic over the internet, other traffic over the MPLS. MPLS is obviously QoS aware, and so you can mark traffic. So I'm just highlighting that to say that that is the art of the possible. So that's the idea here. So rules are passed from top down. Okay, so here you can see I've got my applications, I'm choosing my interfaces. You can see which interface is currently selected based on that criteria. There's that word I couldn't think of a moment ago. And you've got that full running track record here the whole time. Now, you're not limited to simply your latency packet drops, these criteria. You can also use downstream and upstream. Now, what we can do there is we can either artificially steer traffic. So if I come along here to DC1 and DC2, you can see that I've put some bandwidth numbers in there, but these are not real. They are simply ways of me doing traffic engineering, all right? I'm creating a demarcation here. So the upstream here on DC1, I've given it a very large upstream and a very low downstream, and I flip that over on the other side here. Okay, so this allows me to vary how I use these interfaces within the SD-WAN rules. Now, we do have a feature here. Now, this does affect, this is one of the few things that requires a license. Now, remember, you only have the license if you need to use this particular feature, but if it has that license, you can then execute a dynamic speed test across those links, and it'll dynamically populate these with that real information. And that way, say you've got a type of link that varies over time, like LTE or DSL or something like that, you can make sure that your SD-WAN is constantly monitoring that and adapting in a dynamic fashion to make sure that your applications are being steered accordingly. So let's just come back here to the SD-WAN. All right, so I spoke about the performance SLAs. So you can have multiple SLAs across multiple links. So you're not just bound to one. You can see here I've got different SLAs going across my IPsec tunnels based on destination. So these are my servers in AWS in the US and UK. I've got an internet access going out via the hubs as well, as I mentioned earlier. And then I've got my direct internet access via these ISPs, direct ISP links. So I've got these different SLAs, and I can use them intelligently to steer traffic over these links. Now, if I go within here, we can see here that we've got different methods of doing this. Now, these, as I said, are not the only protocols. We've got a multitude of protocols available within the CLI and also within FortiManager. So FortiManager hides nothing. I'm not going to go into FortiManager in this video because it's not the subject and it would take too long. But all the stuff that's in CLI is available within GUI in FortiManager. All right. So the idea here to constrain these is just to keep the GUI simple and do the base stuff that 99.9% of customers will use. So these are the artificial probes. Now, what you can say here is you can say always send an artificial probe, or don't bother sending these. Use actual application traffic. So use elements within the actual traffic, like round trip times, handshakes, TCP handshakes, and that sort of stuff, as your reference for your SLAs, or you can have prefer passive. And this is where it will, if there's no real application traffic going across a link, it will refer back to a pseudo probe. As soon as application traffic starts flowing, it'll then start using the application traffic. I then again specify which interfaces I want to participate in this particular SLA, and you can see the whole time the FortiGate is giving me real-time information, right? So I don't have to keep going in and out of windows. I just hover over things and I can see exactly what's going on. Then I set my target. Well, what is my target for that particular link? What do I think is going to be optimal? So here I've set 150 milliseconds, and you can see here that DC2 for this particular probe for that destination is conformant. DC1 is not conformant. So that doesn't mean it won't use DC1. If DC2 fails, which is the prime, it will then swing across to DC1. All right, but clearly we wanted to use the best possible path. And here I'm saying, how often do I want it to check? Or what is the check interval? So every 2 seconds. Failures before inactive is 2, and that should actually be 2 as well. All right, so in 4 seconds, if I lose 4 seconds worth of probes, then declare a link down. If I see 4 seconds of active again, bring it back up. And if there's a static route associated with that, obviously we're using BGP here, but if there were a static route, then adapt that accordingly. Save that. And there would be the same. Oops, I'm just going to change that back to active there. And there would be the same accordingly. And you can have a running track record in terms of how things are happening here. Now, as I said here, so these are your rules. So things are parsed from top down. Here's where you can see that there I'm using latency, but here is where I'm using that artificial steering of the bandwidths upstream and downstream for different applications. And in addition to being able to use applications, internet services, database, source port, destination port, source IP, destination IP, I can also use TOS marking. So, this is coming. I know what I said earlier in terms of using TOS marking on the internet is a waste of time, but here's the caveat to that. If you have traffic marked within an IPsec tunnel, that marking will be retained within the IPsec tunnel as well as being thrown to the outer header. So the ISP will drop what's in the outer header, but they can't touch what's inside the IPsec tunnel. Now, one of two things: I could either carry that traffic across to my destination and have the device on the other side act upon that. But here is what I'm doing here is I'm looking at traffic that's coming into the FortiGate marked to go out to the outside world, and I'm using this as a way of steering that traffic. So here I've got expedited forwarding, here I've got a short forwarding. If I go in here, I can see here that I've got the bit pattern. So we use hexadecimal bit patterns to reference the type of service. All right. But the point is that when that comes in, the FortiGate will recognize that as expedited forwarded traffic, and it'll send it along the relevant path. And you can see here I'm sending EF along DC2 and a short forwarding along DC1. So hopefully that answers the question regarding policy-based forwarding. It's pretty straightforward. So let's do something here. So a short forwarding is, I'm not seeing any hits there. I've seen some hits on EF. So if I come along here and I do an LS, if I run this script here, so ./TOS 32, okay, I'm pinging traffic there. If I come along here and I refresh this, all right, a short forwarding there is, I've got a hit there straight away. All right, so we know that the policy-based forwarding, or the SD-WAN, is doing its job. Okay, and likewise here, if I stop this and I just ping those IP addresses, so if I ping, now these are the IP addresses in the cloud, 192.168.99.3. You can see that this one's latency is 159, and if I go .4, which is in the UK, this latency is 291. So very clearly there they are taking different paths, right? And again, that is because they are being steered accordingly here. This one's going DC1, which has got the lowest latency, and DC2 has got the highest latency. So you may ask why I'm sitting in the UK. Why is the UK latency higher? And that is because I've got a device artificially injecting latency here for the purposes of my demos. So finally, let's move on to quality of service. All right, so if I come along here to traffic shaping, if I look at my traffic shapers here, I've got two ways of doing traffic shaping. Now, if you've got fixed lines, say you've got a direct connect or an express route, and you know that that is 1 gigabit, 10 gigabits, or whatever, then you can manually define bandwidth. So it's a dual leaky bucket scenario. So I've got a guaranteed bandwidth. So let's just drill into here. So firstly, I can prioritize traffic from a weighted queue perspective. And then I can say, well, what is my maximum bandwidth? So this will be my bursts, and this will be my sustained. So the concept here with the dual leaky bucket is that if there's headroom to burst, you allow it to burst right up to a certain level. Now, the reason these numbers are very, very low is clearly, from a perspective of testing, right? So you would never use such low numbers in a real world, but obviously this is a lab environment. And again, I can use kilobits, megabits, gigabits per second. But basically, this specific shaper was based on EF forwarding, and it was saying, well, if I see traffic marked as such, then clamp it down to that, right? And the same thing here. So again, I could create a rule here, and I could call that Skype. And I could say, well, Skype is voice traffic, so let's give that a maximum bandwidth of, let's say, 5 megabits per second, and a guaranteed bandwidth of 2 megabits per second. Voice is very small traffic, all right, so it doesn't need huge amounts of bandwidth, but you do want to give it high priority, all right? So if I come along here, so there I've created my the shaper. Now I need to create a policy. So I come along here and I say, well, okay, well, let's say Skype. And I can put a source interface if I so desire, but I don't have to. And then I say, well, where do I want to send that Skype out of? I'm going to send it out of those interfaces, all right? And then the destination, what I want to do here is I want to use my internet services database, and I want to go Skype. Okay, and then I use that again, Skype or Teams, same thing. I can use my application. So the QoS is not just, so let's draw that correlation between a traditional router where you're doing QoS, and you may use things like shape deficit, round robin, class-based weighted fair queuing if you're in a Cisco world, read random early discard, all those traditional things. They fine, and then you create your queues with your multiple drop profiles. It's complex, it's a nightmare. And the most important thing, it's not application aware. It's all based on either TOS markings, or it's based on source IP address, destination IP address, source port, destination port, right? Whereas here I'm looking at actual applications, and I'm using application intelligence to make this decision. So again, I'm making sure, here I go source all, I'm making sure that these things are what they say they are, and then I apply the relevant shapers. Okay, I come along here and I use that shaper that I created earlier, and I click OK, and there's my shaper. All right, created and ready to identify that traffic and move that traffic on. So hopefully that's answered the question regarding traffic policing. I think I've covered off everything now. Let's just check that as NAT, BGP, policy-based forwarding, and traffic policing. So hopefully whoever watches this finds it useful moving forward. And I wish you a good day. Thank you.